In this lesson, we're going to continue talking about factoring trinomials. In our previous lesson, we talked about factoring trinomials with a leading coefficient of 1. In this lesson, we're going to look at trinomials where the leading coefficient is greater than 1. So just like with the other lesson, we had a b value and a c value, but we're going to have an a value at the very beginning of our trinomial because that leading coefficient is going to be a number other than 1. So when we do this one, we use what we call the slip and slide method. And the steps to the slip and slide method state that you slip the a value, so that coefficient in front of your variable squared term, you're going to slip it to the end of the trinomial and multiply it by your c value, which is your constant. Once you have done this, you can then factor it like a trinomial, like we did in our previous lesson. Then you divide both factors by the value that you slipped in step 1, so by that a value. Finally, you reduce the fractions and slide the denominator up next to the variable. Let's take a look at a few examples to see what these steps look like. In number 1, you can see that we have a trinomial, and then you can see that the leading coefficient is bigger than 1. It is 2. So our first step is to slip the a to the end of the trinomial and multiply it by c. So we're going to take the 2, which is our a, slip it to the end, and multiply it by 3. So when we multiply this 2 times 3, we get 6. So when I slip that 2 down, it goes away for now. So we're left with x squared plus 5x plus 6, because we've multiplied that 2 times 3. Next, we factor it just like a regular trinomial like we did in our previous lesson. So we set up our two binomials. The square root of x squared is x. And then two numbers that we can multiply together to get 6 and combine to get 5 are positive 2 and positive 3. Step 3. We're going to divide both factors by the value a that we slipped. So the factors are the 2 and the 3. And we're going to divide both of them by this a value. So we're going to bring that a value down and divide both factors by 2. Then we're going to reduce the fractions and slide any denominators up to the next variable. So when I reduce this first fraction, 2 over 2, that reduces to 1. So that would give me x plus 1. When I reduce this second one, 3 over 2, that won't reduce to a whole number. So what you're going to do is take that denominator and you're going to slide it in front of your variable. So that will be 2x plus 3. So if your fraction, when you do step 3, doesn't divide evenly, you take that denominator and put it in front of the variable in the binomial you're working with. And this gives us a final answer of x plus 1 times 2x plus 3. And we can check this answer using the FOIL method. So first, outside, inside, last. Combine the 2 in the middle and get 2x squared plus 5x plus 3, which is what we originally started with at the very beginning of the problem. Let's take a look at another example. So number 2, we have a trinomial, My leading coefficient is greater than 1, so I have to use the slip and slide method. So we're going to slip the 5 to the 6 and multiply 5 times 6. That gives us m squared minus 17m plus, now it's 30, because 5 times 6 is 30. Next, we're going to factor this trinomial as a basic trinomial. Setting up your binomial, the square root of m squared is m, and I need two numbers that multiply to give me 30 and combine to give me negative 17. That will be negative 15 and negative 2. Then I'm going to divide both of those factors, negative 15 and negative 2, by the a. So divide both of them by 5. This would give me m minus 3, because 15 divided by 5 is 3, and then 5m minus 2. Because if I were to divide this 2 over 5, that doesn't divide evenly. So I need to move that denominator in front of the m. So I have a final answer of m minus 3 times 5m minus 2. And again, you can FOIL it to check and you'll get what you started with. Take a look at example 3. Again, it's a trinomial with a leading coefficient greater than 1. So we're going to take our a value and slide it to the c and do 6 times 4. This would give us y squared minus 5y minus 24, because 6 times 4 is 24. And factor it as a basic trinomial, so set up your two binomials, y and y. And then I need two numbers that multiply to give me negative 24 and combine to give me negative 5. That would be negative 8 and positive 3. Now I can take that a and slide it under our two factors, so 8 divided by 6 and 3 divided by 6. 8 divided by 6 can simplify. It won't divide evenly, but it will simplify. So that'll simplify to y minus 4 over 3, and then y plus 1 over 2. So I still have those fractions, so I still want to bump that denominator for both of them in front of my variable. That would give us a final answer of 3y minus 4 times 2y plus 1. And again, you can FOIL this to double check your answer, and I highly recommend that you FOIL on all of these that you have to use the slip and slide method for. One more example. Since my leading coefficient is greater than 1, we're going to take a and slide it to c, and we'll have to do 12 times 5. That would give us c squared plus 11c minus 12 times 5 is 60. Now we'll factor it as a basic trinomial. Set up your binomials. C squared, square root of c squared is c. Then we need two numbers that multiply to give me negative 60 and combine to give me 11. That would be positive 15 and negative 4. Now I'm going to take that a and divide both factors by 12. I know both of them won't divide evenly, but I also know that they'll simplify. So I will have c plus 15 over 12 simplifies to 5/4. And then c minus 4 over 12 will simplify to 1/3. So then we're going to take that denominator and we're going to push it in front of the variable for a final answer of 4c plus 5 times 3c minus 1. If you'll go ahead and highlight on this page 1, 2, and 3. And then on the next page, if you will highlight 4 through 9. And then let's take a look at just a couple more. So remember, when we learned the GCF method of factoring, I told you that you'll always want to check for your GCF first, and then factor it further if it can be. So when we take a look at number 10, off the bat we can see that it's a trinomial with a leading coefficient greater than 1. But before I factor it with the slip and slide method, I want to check to see if there's any greatest common factor that can be factored out first. Between my coefficients 20, 52, and 24, I know that there's a greatest common factor of 4. So I can factor out a 4 out of the whole problem. And when I divide everything by that GCF, I'm left with 5n squared minus 13n minus 6. Now what I have left in my parentheses is still a trinomial with a leading coefficient of 1, but we're dealing with some smaller numbers. So I'm going to use my slip and slide method, and I'm going to slide my 5 to the 6, and we'll do 5 times 6. And as I work this, I'm going to continue bringing down my greatest common factor of 4. And when I slide that 5 down, I'm left with n squared minus 13n minus 30, because 5 times 6 is 30. Next, I'm going to take that a and slide it underneath those factors. Oh, I'm getting ahead of myself. I need to factor that trinomial. Bring down your GCF. It's just going to keep following you down. When we factor this as a basic trinomial, the square root of n squared is n. Then I need two numbers that multiply to give me negative 30 and combine to give me negative 13. That would be negative 15 and positive 2. Next, I take that a and slide it back down underneath my factors, so dividing them both by 5. And this sliding that a back down, it tends to be the step that's forgotten the most, so don't forget to do it. Bring down your GCF of 4. In the first binomial, I have n minus 3. 15 divided by 5 is 3. In the second one, I can see it's not going to divide evenly, so that denominator is going to get pushed in front of my variable. So it's going to be 5n plus 2. So for my final answer, 4 times n minus 3 times 5n minus 2. And you can still check these. So you would start by using the FOIL method on your two binomials and then distributing that GCF. Let's take a look at one more in our multi-step factoring. If you'll highlight numbers 11, 12, and 13, and let's take a look at 14. So 14, I can see it's a trinomial with a leading coefficient greater than 1, but I want to check for a GCF first. Between the numbers 32, 16, and 2, I know I have a GCF of 2. When I factor out that GCF of 2, what I have left inside the parentheses is 16x squared minus 8x plus 1. Now, inside the parentheses, I still have a trinomial with a leading coefficient greater than 1, but my numbers are a little bit smaller to work with. So I'm going to use the slip and slide method. We're going to continue to bring our GCF down. We're going to take the 16 down to the 1. So that means we're going to do 16 times 1. This leaves us with x squared minus 8x minus 16, because 16 times 1 is 16. Oh, that's a plus. Now I have a basic trinomial, so bring down your GCF. Set up your two binomials. The square root of x squared is just x. And I need two numbers that multiply to give me 16 and combine to give me negative 8. That would be negative 4 and negative 4. Then I'm going to take the a and divide it by each one of my factors. So I'm going to divide them both by 16. Bringing your GCF down. So I know that 4 divided by 16 won't divide evenly, but it can simplify. So that's x minus 1/4 times x minus 1/4. So I need to still take that denominator and push it in front of my variable. So GCF bringing it down, 2 times 4x minus 1 times 4x minus 1. Now, since our two binomials are the same, we can simplify this even further. And we can write it as 2 times 4x minus 1 squared. Because you're multiplying the same thing, that 4x minus 1 times 4x minus 1. Go ahead and highlight number 15.